Good morning, everyone. Our next section will be delivered by Dr. Rahul Biswas sir, on machine learning in concrete technology application, challenges, and best practices. Sir has done his BE in civil engineering from West Bengal, MTech in structural engineering in NIT Patna, and PhD in structural engineering NIT Patna. Sir is presently working as an professor in uh, VNIT Nagpur. And now I request sir uh, to start with this session.
Thank you so much, sir. So, I will be delivering my presentation. I will stop my camera and go to the presentation mode right now. Am I audible, sir?
Yes, sir, you are audible.
Audible. Okay, thank you so much. So, my topic of presentation is today machine learning in concrete technology, its application, its challenges, and its best practices. So, my presentation today will be divided into a two part. In first part, we will go through the machine learning, importance of machine learning. I will not go deep into the techniques of machine learning because I will not go to those mathematical calculations that is related to machine learning because uh, why I am not going to that, I will say it in the end of my presentation. And after in the second part, I will give you a case study where machine learning technique has been applied in concrete technology and how we can write good articles using machine learning techniques and what are the flowchart of writing good papers in publication in good journals. So, first at the starting, what we must know what is machine learning. So basically, Herbert Schumann gave a definition of machine learning that learning in any process that improves the performance and that is due to the experience gained in that process is known as machine learning. Also, by Tom Mitchell in 1998, he told that machine learning has three parts. The first part is performance, the second part is task, and the third part is experience. When anything that increases its performance during its tasks with some experience is known as machine learning. Like if a child is given training and with the experience of hours and the child is learning something that is actual a learning, and similarly the machine learning works like any machine learning tools. We have to give them a task based upon our experience, and by giving those tasks with our experience it improves this performance, and this is what is done in machine learning. So why machine learning? Why it is different from traditional programming? So what we do in traditional programming, we provide some input, we give some instruction to the traditional programming, and then we get an output. Like in traditional programming, if you are writing a code in C or C++ or anything, you are writing that z is equals to x plus y. So whenever you are giving any input, was 2 or and y x equals to 2 and y equals to 1, you will get z equals to 3. But it is different in case of machine learning. Machine learning, we provide a set of input and a set of output, and the machine learning and the model or the black box train itself with those inputs, and it will give a result to a new input. Like if we are giving a 1 into 1 is equals to 2 multiplication table of 1, we are giving a set of example of multiplication table of 1, 2 and 3. What machine learning can do, we don't have to put the multiplication table of 4, but it will give the result or approximately accurate result for the multiplication table of 4, 5, 6, 7, 8 and so on. So what is the basic difference is in machine learning models, it trains itself, it becomes more robust than the traditional programming, and it can be used for various type of problems where in traditional programming it is limited to hours experience. Next, when do we use machine learning? Okay, so it is very simple that the machine learning or this AI, artificial intelligence, are used where the human expertise doesn't exist. Women can't explain their expertise. The data are very high, and the models needs to be customized in such a manner. Like recently, some topics are going on like Chat GPT. We are hearing it. I think you may be heard about this in recent days. So, where what is Chat GPT? Is a very powerful AI tool. So human can't answer and write so efficiently or so proficiently in this in manners. So we need some machine learning tools. Like whatever we are writing, we are getting the results in a very less time and in a very expertise manner. So in this manner, so machine learning is used where the human expertise doesn't exist. So why machine learning is important? That machine learning is important because there are some tasks cannot be defined, like the prediction of compressive system in our concrete case. It is a very meticulous process, and the various factors that affect the compressive strength of concrete. So we can't determine it. It is a very so many trial and error methods were done before, but the microstructural properties are there, chemical reactions are there, so everything comes into account. So it is a very complex thing. So for solving those type of complex things, we need machine learning. So and the main objective of this machine learning is to get experience from the previous works. Okay, so the generalization in this context is the ability of learning machine to perform accurately on new, unseen examples having experienced from a learning data from a given data. So there are many confusion. What is machine learning? So what it is different from artificial intelligence, and what is deep learning? So all things are related to each other. So the whole universe is the artificial intelligence, where the computer can mimic like a human, and there are many methods that is involved in artificial intelligence, and the application of artificial intelligence is vast, not only in the case of this engineering field but also in the case of daily life. The subset of artificial or is known as machine learning. It is not different from artificial intelligence, but it is a subset of artificial intelligence known as machine learning. So what we do in machine learning, we include abstruse statistical techniques that enables machine to improve at tasks with experience. The category also includes deep learning now. So in machine learning, basically what we do, we make a model to get a desired output given upon our experience or given upon our set of data. So artificial intelligence is a altogether greater universe, you can say, and machine learning is a subset where we use for generally in prediction and classification types of techniques. And what is deep learning? Deep learning is a modified version of machine learning techniques, because in machine learning we used to get ANN, the basic models are ANN, then RVM, SVM, but the deep learning where the subset of machine learning where we are exposing multi-layered neural network to vast amount of data, where in deep learning it is more accurate, we are using more number of layers, and we are using more complex problems compared to the traditional machine learning techniques. But for your information, if anyone is interested in machine learning techniques, they should start with the traditional models, the very basic model that is ANN. They should start with ANN, and then SVM, RVM, support vector machines are there, multi-adaptive regression splines are there. They should focus on the second subset, and then they may come to the third, that is deep learning. So it is very important to start from the scratch. Now applications. So machine learning applications are broadly divided into three parts. One is supervised classification, supervised learning. The second one is unsupervised learning, and the third one is reinforced learning. So what is supervised learning? From the word itself, it is clear that in supervised learning, some type of supervision is needed. Like when you are giving, suppose you have a set of concrete data of 500 mix designs. So what you are giving that 500 mix designs to the computer, to the tool, and based upon that 500 mix design data, they will generate a model, and they can predict based upon those 500 data. Okay, so in this type of problem, what you are doing, you are supervising your machine learning tool, so to get a result of your experience. Okay, this is known as supervised learning. The two things what are developed in supervised learning, that is classification, which separates the data, and the regression, you might heard about this, that is that fits the data. Okay, so what is classification? Suppose classification mainly deal with the image processing problems. Like in classification, what you can see, uh, in classification problem, if there is a concrete block which has a crack, if there is cylindrical block, if there, when you are going for structural health monitoring, you can see the cracks developed or the rebars. So in those type of image, when you process those image and you want to get a model that can give you the accurate amount of cracks and all these things based on the previous images, that type of problem is known as classification problem. The second one is regression problem, which is much more popular among today's world and in today's system. That is the regression problem, where we want to predict the concrete durability properties as well as the mechanical properties, like the strength of concrete, the softivity of concrete, absorption of the concrete, mixed design attributes of mixed design parameters to the this to these properties of concrete. This type of problem is known as regression problem, where we where why if it is the output is based on A B C D E F G, where A B C D E F G are the input parameters or the properties that governs that output. Now, again, one type of problem, the second part is unsupervised learning. So, unsupervised learning identifies hidden patterns and relationships in a unlabeled data set by grouping data into cluster or by associations. Like for for an example, if you see a child playing with toys, he can arrange them by identifying the patterns based on their color, shape, size, or just based on their interests. The kid discovers new way to cluster the toys without needing external supervision. We don't need to supervise him. He can do it by himself only. That type of problem is unsupervised learning. And the third one is that is more popular now. That is the reinforced learning, where our agent or interacts with the environment, and they take the actions in order to maximize the output. Like here, if you give a particular task to the model will learn by itself and give you the best result it is possible. Like you don't have to supervise it, you don't have to give a set of data or anything. You have to say, I need to predict the compressive strength, and the model which learn in such a way that he wants to give the best possible results for the output. Like if you take an example in practical world, you can see that if you are talking about a chef, he has many type of foods and he wants to cook it. He will cook it in such a manner that the best possible tastes come. Okay. So in reinforced learning also, it will train itself in such a manner that the best possible results come without giving a previous supervision or previous set of data. So this is the three different ways of machine learning, but mainly we will deal with the first one, that is supervised machine learning, which is nowadays as a booming topic, where the classification regression problems are dealt with. Application of civil engineering. So there are various applications of civil engineering. I am naming a few, very few actually, because mainly I am dealing with concrete problems. The topic is related to concrete, so I have given some structural. I have given some these examples from structural engineering aspect. So there are applications concrete in geotech, construction management, transportation, water resource, and whatnot. There are the AI has penetrated in every branch of civil engineering. So, what are the applications? We can see that it is nowadays in structural health modeling. It is being applied very much like in structural health modeling, like for the old buildings or the old bridges, we can put some sensors and get the data from the sensors over the time, and based on that the data we can train a model, and we can predict the life of those structures in very efficient manner. Also in structural engineering, we can do it for bridges, dams, dams, offshore oil ring towers, and many more. I just spoke about concrete mix design, also the prediction properties of concrete, like durability properties and mechanical properties. Also in case of estimation, also we can find the best possible estimations of by which we can reduce the cost effective models can be obtained using this ML engineering, ML in civil engineering. And for geotechnical aspect, we can predict the liquefaction, we can predict the bearing capacity of the soil from transportation, we can optimize the traffic flow, we can optimize the what are the yeah, strength of our pavement, though it can be flexible or your rigid pavement. So there are various applications in civil engineering. So mainly I will deal with the application in concrete technology. So so in the concrete technology, at first the concrete technology, the it was divided in four paradigms. Like the first paradigm, it started in 1920s when first Abraham gave us the relation of water cement ratio and the strength. That's the word strength is inversely proportional to water cement ratio. It was first by him who gave the first paradigm, and from that paradigm we started the process of mixed proportioning by trial and error. We this was a very extensive work. Labors were required. We haven't determined a particular where we can get a formula by which we can predict a concrete. It was always a trial and error process. In today also we are doing a trial and error for getting M80, M70, M40, because it is very important to go through such IS course and many other course for aggregate course, aggregate on this, all this. This was based on the empirical science, and it was the main basic of this was trial and error experiments. In beginning of 1980s, the second paradigm started. That was a theoretical science. But in the beginning of 80s, the development of microstructural models of cement hydration started, and fundamental understanding of microstructural property relationship in concrete was first studies using the law of kinematics, law of thermodynamics, and all this. So, what was the problem? Why we shifted from first to second? In the first paradigm, it was very extensive work. It was time consuming, and it was very hard to get a single model that can predict the concrete properties accurately. Till now, there is no single empirical science model which can predict the properties accurately. So we move to the second paradigm. But still, the drawback of the second paradigm was it was these microstructural models cannot obtain the density functions or molecular when the atomic reactions were not covered in this second paradigm. The atomic for that purpose, the third paradigm came in late 2000s. Okay, so in concrete science, the use of density function and classical molecular dynamic simulation has exploded in concrete science, and because of the ever-growing computing powers. So in the third paradigm, what we started to make the 3D models using this molecular functions and dynamic functions. But still, it has some drawbacks, because in this third paradigm, we are making a model, but we are taking very less number of atomic reactions, atomic interactions in this that paradigm than the actual. Say if there is crores of atomic reaction, we are dealing with only lakhs of atomic reaction in this third paradigm because of the computational cost. Because we cannot take into account those huge number of calculation in this computational science. So to overcome all these drawbacks, all these limitations, the fourth paradigm came, that is known as data driven science. It was far more easy, it was far more less time consuming, it was far more what robust than all the paradigm, and it gave another dimension to the research. By using this data science, we by using this ML algorithm, it was possible to create the models which gave that accurate prediction models, accurate classification models, accurate uh, results as compared to previous model paradigms. Okay, so this is how the data-driven science came into account in concrete technology. So there are some summary of some machine learning models in concrete science. Like the first and the very most popular machine learning technique, that is neural network, or it is known as also artificial neural network. Okay, this is not nothing but it is interconnects the neurons from input to the output, and it depends on the weights that is generated by themselves for creating a model. And this type of models were used in prediction of compression, compressive strength, fractional strength, tensile strength, elastic modulus, setting mirror, and many more. The what to say, the improvement of this model is the second model, that is known as support vector machine. It is different from neural network. It depends on some probabilistic approach where the hyperplane is used to separate the data with different classes. This was also being used with for these properties that's shown here in for compressive strain, also tensile strain, also elastic modulus, elastic constant of CSS gel. So those properties were predicted. Next, a model that came into account, that is decision tree. So this decision tree where the models started to go from ML tradition. These two models, the neural network and shepherd vector machine models, are the traditional models. Now the ML model started slowly moving towards the deep learning method. Like from decision trees, it is much more accurate than the previous one, and it was seen that the feature was to maximize the information gain until reaching to the end of the tree. Like it decision to acts like a tree. When we are giving some inputs, it starts building a tree, and it goes to the end of the tree, that is the leaf, to get the best results. It was, and the random forest is the advanced version of distance decision tree, where in decision tree only one tree is created. In random forest, several trees created to get the robust results. And all the machine learning techniques, all those techniques were used for the prediction properties. Rather that can be a regression problem, or rather that can be a classification problem. Now, how many number of publications were published till now? So based on the researches, it was the data was of 1990 to 2020, of 30 years, and the data this data is collected of 392 data which were published in the good pub journals with SCI impact and with a good impact factor. And from this 394 data which we got from Web of Science, there we have seen that total papers, more than the first paper that was published, that was in 1992, and the second was published in 1994, and later the boom happened after 2000. You can see from the graph that after 2000, after 2015, the boom in the use of machine learning in concrete technology had increased. You can see from the second graph that the most number of models that has been used, that black one is the neural network model, followed by that support vector machine, the decision tree, then the random forest, and the k nearest neighbor. So from this graph, we can see that still there are a lot to study about these models, because the use of those the recent models, the advanced models like the decision tree, random forest are very limited till now. So if someone wants to pursue their research or pursue their study in this data science field, they can come and they can use those advanced models. And up beyond this, there are some more models also. They can use those also, but still the use of this ML is very limited, and there are a lot more to do in this field. So, and if you see the number of publications also, it has increased a lot. Like the only 324 number of publication is from neural network only, and if you go to the recent models, the number of publications are very less and the studies are very less in this for these models. So it is my suggestion that if anyone wants to pursue their research in concrete technology, they can opt for this machine learning techniques, and therefore they can incorporate data science with this computing technology or concrete technology, and they can give a boom to this study. Now, what are the properties we are predicting? We are predicting mainly three types of properties. One is property predictions, that is the strength, that is the crack, that is any type of regression properties. We can do also material characterization using some X-ray computed tomography. From that, we can get the data and then we can predict the pores, sands, fiber, the matrix, the atomic bonds, and everything. And the third is material simulations, which is a very less studied portion till now. It has not been studied unless only few numbers, like 5 or 6 papers are there for material simulation, where we study about large scale molecular dynamics, simulation of calcium silicate hydrate using ML potential. This study, the third C, has been studied very less. So it is also a topic of your study. It can be also a topic of your research, which has been explored very less till now. Now, there are, but it is not easy. There are some challenges related to this machine learning. So, the first challenge is the data challenge. Okay. So, what are the data challenge? The quality of data, which represents. Suppose you are getting a data of misdesign from a site or from a lab. How good the quality of the data? Was the concrete was cured properly? Was the mix was done properly? Was the parameters were studied properly? These all things can affect your model. Also, the sparsity of data is daunting. The daunting to collect and organize this experimental data in systemic manner it itself a very difficult job, because see, for a machine learning technique, you can't go with the 10, 20, 50 data. It was in past. Now you need at least 500 to 1000 data. If you want to build a very good model, you need at least more than 500 data. So from where you will get this 500 misdesign data? From where you will get this 500 crack data? So to collect those 500 data is itself a very difficult job. So that should be kept in mind that those data which we are collecting should be accurate. But again, the factors that affect the output of a concrete property is also very high. Like if we are talking about fly ash, there is fly ash. There the properties of fly ash are there. Fly ash properties differs from every source. Also the concrete properties, cement properties, sand properties, the chemical properties, the physical properties changes. So there are the dimensionality of this data are very high. So we should achieve a sufficient confidence over those dimensionality of this data. Otherwise, your concrete model will not be in similar manner. It will not be a robust, or it will not be a very good tool to predict those predictions. Okay, those outputs. Now there are many biases also, like representation bias, measurement bias, temporal bias, deployment bias. Like representation bias, I just told, if you are taking a bias, it when we're using a prediction models, you are taking two source of data for two sources. Suppose you are taking a mixed design from some literature review of some author, and again a mixed design of other some author, but he is using a type C class C flyers and someone is using a class A flyers. We don't take into the account the, we only take the flyers. We don't take account of the class of the flyers. So this is how we are presenting some representation bias, because the class is important, because of that class the chemical proportion are also changing, but we don't take account. Measurement bias, the measurement bias also occurs because of the way the variables are selected, collected, and computed. One possible issue in concrete studies is that the variable of models are often oversimplified. For example, the quality of sand, we don't go to the chemical analysis. We just add. When we measure, we can add 1 gram more, 1 gram less. In the site, it is not possible to put accurately. So these measurement biases are there. Now coming to the temporal bias, which arises when the population or the behavior differs over time. Like the chemical and physical properties of cementitious materials have been changing over time due to various factors like production technology and raw material supply, which leads to a technology and which leads to a very defective models. So these biases are like deployment biases, are how we are deploying the concrete, how it is curing. So those biases should be taken into account. Though uh, it is very difficult, but we should minimize the errors. Now you will say that, sir, you are talking about 500 data, 400. How can we make this data in lab? It is not possible to make 500 mix designs. It is very next to impossible. For a single study, you want to make 500 mix design, 400 mix design to get a robust model. It is very difficult. So there are data. If you go to the internet, there are data from 2007 to 2018. There is almost six data related to concrete. That one is for compressive strength. You can search almost 1,300 data are there. Also in 2015, there are the data for creep and sinkage, about 400, 1,400 data for creep and 1,800 data for sinkage. Recently, for classification purposes, the concrete crack images are given. There were 40,000 crack images with 227 into 227 pixel size as given, which can be used for your study. Like what you can do, you can take the for 2000 data, you can take 1030 data for training your model, and you can make this concrete in your lab, and you can use it for your testing for the validation purpose. This is how you can make a robust model also, and you can validate your result also. Now, what is the workflow of machine learning in concrete science? So what we do, how we, now it is important, how we follow, how can we do. So first step is going to the literature reviews. You have to determine what type of model you want to make. Like, are you going to make a prediction model for compressive strength? Are you want to do you want to make a prediction model for slump? Do you want to make a prediction model for durability properties like softivity, absorption, water permeability, RCPT, rapid chloride penetration test? This is this should be done by you, and based on your literature survey and your research gap, you need to do some experiments, or you need to find the data that can build a model. So the first term is problem definition. What type of application you want to make? What are the current practices, and what is the research significance where you will define the novelty of your work. Based on this, you will start preparing data, whether by experiments or whether by collecting the data from the literature. Then you will go for data pre-processing. This is very important. In data pre-processing, what we'll do, we split the data in training and testing. One training, what is training? Training is used to train the model, because we are going for the supervised learning. We will train a model based on some given data set, and from data testing data, we that is used for validation purpose, the whether the model is working on another set of data or not. Again, in data preparation, pre-processing, what we do, we will see that whatever input parameters we have selected, whether it is useful or not, whether it is affecting the output or not. So these all things should be determined, because we cannot use such input parameters which don't have any effect on the output. Like if you are selecting compressive strength, okay, and you are selecting some parameters like cement company, you are selecting your SCC 100, because it is not important. The chemical composition of cement is important. The company is not important. The company will not affect the uh, strength of that concrete. So it is very important to which features are affecting the output and reduce the dimensionality of the data. Then what we'll do, we will select some data on traditional data or some hybrid data, and then we will evaluate the data. We will tune the data, and we will get a result. Then the result should be processed. The result should be analyzed, whether the data result is good or bad, whether the model should be run, whether the model should be again tuned, and based on the tuning, when we get the desired output, we will get a toolbox for prediction. So this is how you will do. First problem definition, then data collection, then you will process the data, then you will develop the data, and then you will evaluate the model. Okay. When you make a model, you have to evaluate whether it is good, whether it is robust or not, and then you will deploy the model. So this is the summary of the first part, that what we are doing to do. The field of data-driven concrete science has recently experienced a huge surge of interest. It is true, and machine learning models being applied for accurate property prediction, advanced material characterization and analysis, and accelerated simulation of increasingly complex cementitious system. Right? Also, we have understood tuner what is the importance of data preparation, model validation, and model interpretation. And in doing so, what we can see that we have understood the critical need of sharing data and methodologies, linking laboratory and field data. Okay. Now, till now we understood what is machine learning, a very basics of machine learning, how the flowchart of machine learning works, how the dimensionality of machine learning should be reduced. Now, what is the application? How we can apply? So I will give you a brief case study that affect efficiency of computing techniques for prediction of compressive strength of geopolymer concrete. This is a published paper in Computers and Concrete. It is my paper only. And here in this paper, I have studied geopolymer concrete, which is very booming topic right now, which is a very what to say interesting topic in today's world because of this cementless concrete and use of soft computing techniques for this, for the prediction of compressive strength. So in this case study, what we will learn two things, that we will learn about geopolymer concrete also, and how we can apply the soft computing techniques, and what is the process of writing papers. The topics, the so first we will start with introduction. So in introduction, we can say that in recent years, the flies-based geopolymer concrete, for its similar properties like Portland cement, as well as its environmental sustainability, is extensively researched, because we know that this geopolymer concrete is a cementless concrete, and the consistent method for geopolymer mix design is very much important, but it has some complexity and uncertainty of its design parameters. The design parameters which affects the mixed design of geopolymer concrete includes alkaline solution concentration, mole ratio or molar ratio, liquid to fly mass ratio, many things. So this complexity, there is a lot of complexity in mixed design of geopolymer concrete, which needs to be addressed properly. Recently, IS code also has also came, but the standard deviation is also very high in this. So there should be a proper model which can give a accurate result for prediction of geopolymer concrete strength. Still, to overcome these difficulties, the study aims to provide a simple niche design tool using AI models or machine learning models. Okay. So, what is geopolymer concrete? We know that around 2.8 billion tons of Portland cement is used around the world, and it's not 4 billion. Actually, it is 40 billion tons per annum will be used. It is expected to rise up to 14 billion tons per annum. So it makes concrete the second most consumed material in the world after water. So we can see how huge the concrete is being used in this world. Okay, and we also know that for 1 kg of cement, almost 1 kg of carbon dioxide is emitted. So we can see how much carbon footprint is there for a cement production and for a concrete production. So to overcome this, the researchers are going for cementless concrete. Okay, to battle this demand of cement and reduction of carbon dioxide emission. So for this, in 1991, Davidovic developed an inorganic polymer to replace cement in the future, named as geopolymer. What is geopolymer? In geopolymer, Davidovic used two types of solution, that is sodium hydroxide solution and sodium silicate solutions. Based on that, the geopolymeric reactions takes place, and the strength of that material, that is known as geopolymer, is somewhat similar to our ordinary Portland concrete cement. So it was used as a supplement of Portland cement. But there are two types of geopolymer concrete. The geopolymer term came because of fly ash. If you use 100% fly ash for a concrete, and we use a geopolymeric reaction, then it is known as geopolymer concrete. But instead of fly ash, if we use any other material like GGBS, it is known as alkali activated silicate concrete. Okay, or alkali activated concrete. Why this is the difference? The geopolymer concrete needs a it cannot be cured in ambient temperature because there are no calcium content in it. But for alkali activated concrete, like for GD-based concrete, it can be cured in ambient temperature. So this is the basic difference. Both are in both concrete geopolymeric reaction takes place, but the fly ash concrete is known as geopolymer concrete. Okay. So what is the research significance? So from the if you write a paper, it is very important to introduce something and then write the research significance. So because the research significance of this paper of this study is the labor intensive trial and error test performed to achieve the optimal geopolymer mix. So there should be some alternative process to get a accurate model prediction models, accurate mix design, so that we can it can be used for the engineers and the use of geopolymer can be increased. So in the present study, three AI based models, namely generic programming, relevance vector machine, and Gaussian process regression has been adopted, and five parameters that such as mole ratio, alkaline solution in liquid phase, liquid to fly ash mass ratio, curing time, and temperature are considered as input parameter to predict the compressive strength of this compressive strength of geopolymer concrete. So in the subsequent section, I will discuss about the models in very brief manner, like genetic programming model. I will not go to the mathematical calculation as I said before, because the reason is if anyone is trying wants to try this AI techniques, they should not go to the mathematical calculations, because everyone is trying to use this machine learning, but they get afraid because of those complex mathematical problems. So let me tell you, you don't need those mathematical calculations. This NNC, SBM, RBM, any type of models, it is a built model by some renowned scientist. What we have to do, we have to apply those model in our study. We don't need to go to those mathematical calculation. We don't need that. We will see how can we apply to our study. So I will suggest you take a model, you take the code, and just try to put your data in it, and just try to but tune some little parameters. Don't go for the high parameters. Then it will be very easy for you. And if you want to go deep into the models, it will be very complex for you. So here, like genetic programming, it was first developed by COSA, which is based on symbolic optimization algorithm. Next, this genetic programming model was combined with GA genetic algorithm model, which is based on the principle of Darwin. And this GP is normally a tree-based model. What we do with we generate an initial population and we select program based on fitness. Then we start crossover mutation reproductions and then we terminate the criteria when it is satisfied. Later we get the best solution and we end the program. So like this we get the output. In relevance vector machine also, it is the advanced version of SVM we can say. What is the main thing? With for SVM it needs much more number of kernels, but RVM we need very less number of kernels. And one of the main advantage of using RVM is we get a equation from this, like from ANN GP in this model we don't get any equation, but RVM gives us the equation for prediction. So this is how RVM is very new model. And the next model is Gaussian process regression model. I think the equation is not visible here. It was present in the presentation. I don't know. Okay. It is also a kernel-based probabilistic model for prediction of a function or for a given data. So how can we get those models? You will search in the Google the code of genetic programming model. You will get a code for Python or for MATLAB. You just download the codes. The code is written in a very well mannered way. You just have to change the input as per your study and you can get the output result. So this is how you will do. So what is the data collection? For this study, what we have done, I have used the data from Ling et al. He has collected almost 300 data. I used those data. I divided the data into two parts. One is in training and one is in testing. For training, I used 70% of data, like 210 data. I made a model using those 210 data and I tested using remaining 90 data. And I saw that the robustness of model, how the robustness of model. So before proceeding further, I started, uh, I performed some statistical visualization of the data. So to study that whether the data is affecting the output that is consistent or not. For this, I have done some statistical parameter, read some statistical parameter, how the various variation of the data is, and from the kurtosis and skewness, I saw that the variation is very less. So the dimensionality of this data is very less, so it can be used. Next, I have performed a Pearson correlation. In the Pearson correlation, what we can see that this compressive strength, the effect of all the parameters are very high in this compressive strength. Like for molar ratio, that's MR, it is -38. For alkaline solution, it is zero point 0.4. For liquid to fly ash, it is 0.28. For temperature, it is zero point 0.3. For air, it is 0.42. So you can see all the parameters which are affecting the compressive strain is very high. So from this uh, study, from this matrix, I can conclude that this all the parameters are has very high impact in compressive strain. Thus, it can be taken as the input parameter of the study. If any of this parameter had a value of less than 0.1, I wouldn't have taken it as a input parameter. Like it won't affect the CS at all. So why should I make the model more complex? So I have to reduce those parameters. If you are going to study, you have to see this thing first, that which parameter is affecting your output. If it has a very less effect, we must omit it. Otherwise, your model will be very high dimensions. Model will have very high dimensions, which will affect the efficiency of the model. Later, we can also use sensitivity analysis. This is based on cosine amplitude method. Do you know from the cosine amplitude method also we have seen that all the parameters have high sensitivity from ranging from 0.6763 to 8150. None of the parameter has a sensitivity less than 50%, and the contribution of all the parameters can be seen from this donut diagram, that is from 18% to 21.87 percentage. So all this study was done to verify the effectiveness of input parameter on the output parameter. Only one study is not suffice. Like the from this data preparation, you cannot conclude that it is important. The input is important. You have to do three, four parametric analysis. Then you when you, I think the equations are not visible here. Is it visible? Hello,
Hello.
hello.
Yes, sir.
Sir, I think some of the equations are being not visible in this PPT. Maybe
Okay.
I will continue, okay, because there were some equations. Fine, I will continue with it only.
Okay. Okay. Sure.
So, I think the equations are not visible here. Still, if you someone to contact with me, I will give you the equations. The equations are like R square value, variance account factor value, performance indices, Wilmot index, RMSC, MAE. These all are the statistical parameters which can determine the efficiency of models. You have to calculate these parameters based on your output results. Okay, and the ideal value of these parameters are these given in this below table. You can see that if your model has a R square near about 1, it is a very good model. If your variance account factor is near about 100, it is a very good model. Performance index is near about 2, it is a very good model. If it is somewhat, if the RMC is near to 0, it is a very good model. So you have to see, you have to this parametric analysis. Otherwise, you can't perform. You can't know the efficiency of this model. So based on this, now we will come to the results and discussion of the model. Like from here, what we can see that GP model, that is genetic program model, for training, the model has achieved the R square of 0.9362, whereas for testing the R square value is 9291. Similarly, for RBM it is 99 and 90 respectively, and for GPR it is 0.98 and 86 respectively. From this figure, what we can conclude that for GP for training, the RBM has given the best result with 0.9905 R square, whereas for testing the GP has given the best result with 0.9291, whereas the GPR has underperformed in training, in testing, and the GP has underperformed in training with 0.93. So if you see marginally, the RVM is the best model because it has given a respectively good result in both the phases, in training and testing also. But you cannot conclude this from one figure. You have to do some more analysis so that can conclude, you can come to the conclusion which model is giving you the best result. So for this we are doing one more analysis, that the details of performance parameter in the training and testing, the same thing which the equations were not shown there. By those equations I got the value of R square, VA, PI, and from this chart we will just compare with the ideal values, and we will see which of the model is closer to the ideal value. For like PI value, the RV has 1.95 for in training, which is the highest, and the GP has 1.77 in training testing, which is the highest. Whereas the GPR has the lowest value in the testing. So similarly, all the parameters should be checked and the ideal value with the ideal value, and we can come to the conclusion that which model is best. For here, we can see for testing RVM is good, but for training, sorry, for training RVM is good, but for testing the genetic program is the best model. Later, the very important diagram, that is Taylor diagram. From the Taylor diagram, we can see that uh, this Taylor diagram is a 2D diagram which gives you three types of parameters. One is the correlation, one is the RMSE value, and one is the standard deviation. And the one which is given here, it is the reference point. Those models which are very close to the reference point is known as the best model. And from the visualization perspective, we can see the blue models RVM is close in the testing training, and the red model, that is GP, is close to the training. Similarly, for area over the curve, it is known as regression error curve. And regression analysis, regression error curve analysis. And from that analysis, what we get, area over the curve. So those model which have area over the curve more, that is less performing model. Like for first figure, you can see the area over RVM is very less, this blue one, because so that we can conclude this RVM is performed best among these two. And for second plot, we can see the red one has the less area compared to other. That is, and red and blue has a less area, but the black has the most area. So for the both the purpose, we can see that these black portions are not that good, and the blue and red are very better performing models. So we can conclude that the RVM is, for every aspect, RVM is giving the best results. From last analysis, that is rank analysis, and it is very new and very efficient analysis. From this rank analysis, we can see that RVM has achieved 30, whereas GPR 18 and GP 12. In testing, the genetic programming achieved the rank of 29, followed by RVM and 10. So from these two, from training and testing, we cannot conclude which is best. Like for RVM, it is best in training, and GP is best in testing. But when we go for a combined analysis, we can see that RVM is giving a rank of 51, whereas GP is giving a rank of 41, and the least performing model is GPR. So finally, we can conclude that the overall best performing model is relevance vector machine for the prediction model of this. And also we saw that RBM is giving the R square value more than 90%. So it is a very robust model also. And RBM is just followed by GP, and the least performing model in this study is GPR. So from this we can see that we got RBM model which has a generalization ability, but there is no thumb rule available. You have to do trial and error test for searching the best possible combination of hyperparameters for this model. This is one thing that is the limitation of this work, which is little bit time consuming, and which is the main advantage of this machine learning technique is the trial and error process by which you are searching the hyperparameters of the, like, for which parameters RVM will give you the best result is a matter of disadvantage in this type of work. Next, though there is a limitation, RBM model can be used as a new alternative to assist engineer to estimate the composite strength of geopolymer concrete in civil engineering, and the future direction of the work can be rigorous assessment of hyperparameters, implementation of meta-heuristic optimization. I haven't covered this part, but it is a most popular part right now. This is the implementation of meta-heuristic optimization. You heard about particle sum optimization. You heard about Harris of optimization. What we do, what is what is the limitations of the work can be overcome using this optimization techniques, because this optimization will help you to find the best hyperparameters without the trial and error process. So this is what we can go for future generation, and it is also being done right now. Validations of the models, because I have used only 300 data and it was published in 2018. But now you need large number of data, and the generalization capability of this study should be more. Like some more analysis, like SAP analysis, uncertainty analysis should be performed for the generalization capability of this parametric studies. So these are the few references, because lot more references needs to be added here. And thank you so much. Here I conclude my presentation. I hope for a small question answer session.
If participants have any question, they can mention it in the chat box.
Mm. I think no questions are there.
Okay, so then we will conclude the session.
Yes. Is there
Uh,
any question? Have you seen anything?
so we will be sharing a link for the feedback, and
Okay, okay.
over there, if they want to ask any question,
If
they
there is
can mention over
anything you
there. Huh?
can, yes, 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 yes. And if they want anything related to this,
Yes, sir.
I will be very happy to help them.
Okay, sir. Sure, sir.
Okay. Thank you
So
so much.
then we should conclude, sir.
Okay, okay.
Thank you so much, sir.
Thank you. Thank you so much.